Let's dive right in with configurations and amplitude.
Cool. So I think the main thing that these posts are doing is treating reality the way it actually is. And to caveat that, we have to say that the way reality actually is, we are going to be assuming for the points of these blog posts is that it's actually math. I'm not sure if that's controversial to say or not. I think most physicists would agree with that, but it is an unintuitive thing. The point of these blog posts is to explore what it would be like if it was simply acknowledged by everybody that everything is just math and that reality was taught that way rather than being taught that reality is distinct objects that are acted upon by forces. Does this make sense so far?
Yeah, I mean, the thing is that like, what is math is actually the kind of thing you might want to ask a philosopher about. Um,
Mm,
like, are numbers real? Certainly, sets of objects are real. I can count the number of things on my desk or something, but is the number five a thing? Certainly, is the square root of -1 a thing?
yeah.
This is where, not that I fell off the train, but it's like I drew the short stick on the interest lottery on this. Like, I want to be interested by it and be engaged by it, but I have never been interested more than just a passing familiarity with quantum physics.
Okay, so let's take the very first example he gives as a quick example of this, where he describes a photon moving from an emitter like a laser to a mirror, and what happens when it does that, because this is a half-silvered mirror. What happens is that you have an equation that describes the photon. That equation changes when it reaches the mirror, and it becomes two. I'm not sure if I'm using the right word here for this, but two amplitudes.
Right. It becomes a larger equation.
Yes, thank you. There we go. It becomes a larger equation that has both the amplitude of a photon moving from the mirror in one direction and the photon moving from the mirror in the other direction, because this is a half silvered mirror. The thing is, this is just the actual base level reality. There was one equation for the photon moving towards the mirror and a different equation for the photon moving from the mirror to somewhere else. That's all there is. And the post starts out with saying, you're not going to believe this, but early scientists thought that when the photon got to the half silvered mirror, sometimes it would go in one direction and sometimes it would go in the other. Haha, like a photon will do two different things randomly. And, it's pointing out that earlier we thought that things were particles. And if we saw a photon, ultimately, if we saw a photon go one way or the other, we would assume that one thing had happened or another thing that happened, rather than that everything is just an equation that changes in amplitude over space as time progresses and it interacts with other objects. It is the math, right? The math just changes and it describes both things happening.
This is the where I fell off in math in school too. It's the complex numbers, complex being ones that involve the
Mhm.
square root of -1. Maybe I did miss the thrust of the point then. My understanding was that you shoot a photon at this half silvered mirror. It's not like the photon makes a decision or that it's random or something, but that there is a configuration amplitude of, and maybe we should stop using those words. Uh, but there's a set of circumstances, the way that the universe is all set up with the mirror and the photon, and that determines the likelihood of the outcome. But I think maybe I'm missing it.
There isn't a likelihood, like both things are happening at the far up here on many levels removed up in our scale of things. You can't measure these amplitudes directly, but you can measure their squared modulus by counting up how many photons arrive at detector 1 versus detector 2 over many trials.
Right. We can't look at the mirror and before experimentation give you the configuration.
Right.
We can only get that after we run experiments on it and then determine after the fact what the configuration amplitude is of that configuration.
Yeah. You can back out the. God, we're going to sound so stupid because we don't have a math background about this, and I apologize to everyone. But you can back into what the amplitude must have been.
Right. A really, really bad analogy would be I'm handing you an unfair coin. You can't tell me how unfair it is till you flip it 1,000 times.
I think that's fair.
To me, that's perfectly intuitive. And I guess, the sequence is to make quantum physics more intuitive, but that's not, I think, a good
Yeah,
analogy because
I
that's
think.
we're not dealing with configuration amplitudes. We're dealing with a biased coin. Like it's a much simpler to parse concept and just much more in tune with how we usually work with reality.
Yeah. The interesting thing about this is that the amplitude flows can sometimes cancel each other out. Since they are complex numbers and you're sometimes multiplying by negatives or by factors within the complex numbers, all the amplitudes going to a single location. Once they interact with another half-silvered mirror, the ones going one direction may be both positive and negative to the exact same amount and cancel each other out. Two amplitudes can cancel each other out because they are exactly inverse of one another. And therefore, that detector will never detect any photons. It'll only detect the ones going to the one in the other direction where the two amplitudes did not cancel out.
Okay, I think I'm with you so far.
The interesting thing about all this is that these are actual experiments that were done in real life, right? And when you don't know that reality is just equations, and you're still thinking in terms of particles, when you have this particular setup of mirrors, it kind of looks like a proton is remembering if it passed through the mirror or was deflected by the mirror the prior time. That starts introducing mystical thinking into the world model, because how could a proton remember anything, and start alternating things? Whether that one photon remembered if it had bounced or gone straight through a previous mirror. So additional experiments were made when they blocked one of the paths, and if the proton is doing the thing where it remembers what it did before, so once it's deflected and once it bounces, or vice versa, they should get certain experimental results, and they didn't. As soon as they blocked it, things went back to going 50-50 to the two detectors, and this was very confusing because people are still thinking about things in particles, and they didn't realize that they were literally changing the amplitude flows that go to the second mirror, because they blocked one of the flows, so the one that was coming through the other path to cancel it out wasn't there anymore. This created a lot of confusion historically due to thinking of reality as particles that are doing things and have a possibility of not doing other things.
Yeah, a couple things to keep in mind with these. Like, well, so one, all of our talk of bouncing off mirrors and whatnot, there's some good diagrams that help with that in the post. But like more higher level, I think I'm asking myself, what is the point of this? Like, how does this make me a better rationalist to understand this? And I think the answer is like understanding this particular concept doesn't. What I think the point of this is like, here's something that people say is inherently mysterious. I'm going to show you that it's not. Nothing is inherently mysterious. Mysteriousness is a property of your mind, not a property of reality. I think it's just useful for me to keep that in mind, because why do I need to know this to be a good rationalist? And like I said, I think the answer is you really just don't. But this is a good example of how do you take the tools of rationality and apply them to a quote unquote mysterious phenomena.
Yes, but also I think this is trying to really trigger your weirdness senses, because we think of things as existing as objects. Part of the point of him conveying it this way is trying to portray a society where nobody has the intuition from early on that things are objects, and everyone realizes that everything is just math, and that thinking of objects is the weird, wrong thing that we use to get through the world, but is not what the world actually is.
I would say it's the wrong but helpful and convenient shorthand that is totally adequate enough to get us by in the real world. Like
Yeah.
it doesn't behoove me whatsoever to think of configuration amplitudes when I'm dodging traffic. You know,
Right, yes.
like I should be thinking in terms of cars and where my physical body is. Right.
Yeah.
I think a much easier version of this would have been just like talking about the gene-centric view of whatever evolution on Earth. People are historically taught, no, it's animals. Those are what respond to the environment and evolve and stuff. And it's like,
Mm,
sure, but animals are made of genes.
yeah.
And so it's much easier to convey that. Like that would be a couple 3 posts maybe, rather than a whole set of I don't know how many these are, but several, because that's a much easier thing to get around. But it is another kind of thing where your usual model of reality runs counter to the way reality actually works.
I don't think that in explaining that would trigger people's sense of mysticism, whereas this does. And I think that's an important part of the sequence about showing how readily humans fall back into mystical thinking when things don't seem to make sense.
Oh yeah, no, that's a good point too, for especially the historicity of this case, where there was all kinds of weird explanation, weird proposed explanations for why things were happening.
I want to give the example that is in the third post of this sequence called distinct configurations, because I think this is both intuitive that people would think this way and indicative of how humans go wrong in general, and also, explains why Deepak Chopra and all the other New Age mysticists cling onto quantum theory so tightly.
I think that just in a sentence, though, the reason Deepak and his ilk cling to this is because the public understanding is that no one knows what this means. So, I'll say I know what it means, and it means this thing that you can buy from me. I don't have a good model of Deepak Chopra in my mind, but I don't think he actually believes half the shit he says, but maybe he does.
Well, I mean, even the early scientists believed this stuff, which was part of the problem, because it really is very confusing and seems like magic when you are thinking in terms of particles and forces rather than in terms of everything is equations that change over time.
Right. Deepak makes a lot of like oddly specific claims that don't mesh with the confusions that real scientists had. But let's leave him aside and we can keep going. Aside is a great place to leave Deepak Chopra.
Absolutely. So, as we had said earlier, that when you're running the experiment, the amplitude flows cancel each other out when they go in one direction, and you really have to go back to the post to get the details on that. I can't explain them on the podcast here. If you can spend some time, like really sitting down, looking at it, and taking a half hour reading the blog post, you can get how this works. So the amplitude flows cancel out when everything is unobstructed and transforming in the way that the experiment is set up. And when you block one of the paths to test whether the photon remembers things, then all of a sudden this breaks down. And that's because the amplitude flows are no longer canceling out in one direction. And this is a rather confusing effect for people who model these things as particles and are trying to figure out what the rules of the particles are, rather than what the rules of the transformations among the equations are.
Right.
Right. So it looks like the photons don't just like remember where they went, but they need for there to have been an option for them to go either way. If there isn't the option, if you take away the option by blocking one path, then all of a sudden they don't act like this anymore and they follow strict rules again. That doesn't possibly make any sense. Like, why do they want to be able to go both ways? We know now that it's because the amplitudes were going both ways. It wasn't one particle choosing to go one path or the other. But they're like, okay, so what if we, instead of blocking the path, we just put a sensor along one path so that as the photon is passing by it, the sensor detects the photon and it detects which way it went. And this way, the photon is still completely able to go either way, right? Nobody's stopping it. It's getting that option that it seems to need to have in order to interfere with itself. But we're just seeing which way it really went so that we can make measurements. And so they put the sensor, which doesn't block the photon, and the mysterious phenomenon still goes away. The reason this happens is because amplitudes take every particle into existence. Like, it's not just the photon, it's the photon plus the particles in the mirrors, plus the particles in the detectors. Like, all of that together makes one absolutely massive equation.
Which might nicely be called a joint configuration, which is the name of the post.
Exactly. But more importantly, it's only one massive equation for the purposes of the experiment. In real life, there is no sandboxed experiment somewhere. The actual joint configuration is the entirety of the universe. That is just the most incredible massive equation ever that has a term for every single thing within it interacting with every other thing, which you can only do with a computer the size of the universe. This is not known to the scientists at the time. So if you have a particle somewhere along the way that is knocked out of the way by this photon passing, that changes the amplitude. And so the two amplitudes traveling between the mirrors are no longer the exact same numbers. And so they do not exactly cancel out anymore. And you wouldn't get this weird behavior where two of the amplitudes cancel each other out. And so you only get detection on one detector. So it's not just that they put a wall in one of the paths that caused this amplitude to not cancel out with the other one correctly. It's that if you put something along the way that interacts at all by, for example, being moved out of the way, it'll change the amplitude. And so they don't exactly cancel out anymore. And if you have a particle that is knocked out of the way, and that triggers a bunch of atoms in a detector, and that triggers a bunch of atoms in a display, and that triggers a bunch of atoms in a human brain, you are now moving septillions of particles around by having this little detector along the path. So the amplitude has changed drastically. These are not the same two amplitudes at all. But what it looks like to the humans is that if you even set up a detector along the path of the photon, then immediately the strange phenomenon ceases again. The amplitudes don't cancel each other out, and you don't get the mysterious behavior where only one detector gets the atoms. And so, what it looks like to the humans is that not only does the photon want to have the option to go in either direction, but also, if anybody could even in theory know which way it went because by setting up a detector, then it stops working as well. So it wants to be able to go in either direction, and it wants to be hidden, because apparently if somebody knows which way it went, then it takes away that optionality, right? That means you can't look at anything too closely. It is mysterious by its very nature. That means that mind is fundamental after all. That conscious awareness determines our experimental results. This is what set off all the mystics that, like Deepak Chopra. What else could this possibly mean? Everything works fine unless we're trying to look at it. And if we try to look at it, then it stops working. But if we turn away again, then it starts working again. Like, whether we're paying attention or not seems to matter. It's even found in physics textbooks. Apparently, when he wrote this in 2008, it was still appearing in some physics textbooks. That is what people like Deepak Chopra latch onto. They're like, look, when scientists ran tests on the most fundamental particles in the universe, they found that if you're looking at them, they act differently than if you're not looking at them. This means human awareness is an integral part of the universe. There is a function somewhere in the laws of nature for human consciousness and human awareness, and that is why you can affect things by having really strong intentions at them, right?
Yes, I follow where they fell off the ladder there.
Yeah.
But I guess to give the scientists of old a pass, I mean, these were generally confusing results that they're trying to mush into their old model, So, like,
Yeah.
it was kind of hopeless from the beginning for them.
Right. When you think that things are made out of particles rather than that everything is math equations, I mean, you're fucked from the beginning, right?
Right.
You aren't going to get the right answer until you rethink your very fundamental models. I think he's a bit salty that in 2008 this is still being taught, and and the thing is, it's still hard to imagine no particles existing on the fundamental level of everything just being numbers. Like, sometimes we're asking, are numbers real, right? And the answer could very well be that numbers are the only thing that's real and particles are the illusion.
It challenges our conception of what real means.
Right.
But there's nothing wrong with doing that. It's just, I mean, this is, I think, the intention is this grinds up against my intuition, and I'll just do both things. Is like keep this fact in the back of my mind, but really as a thing that doesn't really matter in my day to day, and continue to think of the world as objects, whilst knowing that at the bottom it's not little billiard balls, right?
Yeah. As we go further on into the sequences, I've had to read ahead a bit to prepare myself, because my God, this is the worst sequence in the world for intuitive understanding. I'm reading them 2 to 3 times as we're going through this right now. He does explain in upcoming sequence posts why things look like they are distinct particles, and it has a lot to do with all the amplitudes canceling out in exactly the right way, so that the only amplitudes that remain look very much like particles up on our level. But on the base level, there's still all these different amplitudes, and it's just the fact that most of them are canceling out that makes our reality look the way it looks, which we can discover if we have small enough and precise enough controlled experiments like these shooting lasers at half-silvered mirror types.
Totes.
Did that make some sort of sense?
We'll have to find out.
Okay.
I mean, I followed it, but also read the posts, and I think it's
Reading
just
the post is pretty important for these.
yeah, which challenges intuition, but that's the whole point here, right? So I'm with you so far.
Okay. The thing to secondarily point out, and the reason some people really dislike the sequence, is that this is not the only interpretation of quantum mechanics, and some people don't like this one. I was convinced by Eliezer, as you read further into the sequences, that this is the only one that makes sense if you don't believe in magic. But that is something that comes up much later. We'll get to it in a couple months, I think, at the rate we're...
Couple months. That's discouraging about how long these are going to be, or how long the sequence is. But that's the job. We're reading the sequences, so
Right. I knew we were going to get to this eventually when we started this project, and I was like, that's a problem for future Eneash.
Yeah.
And now here's future Eneash being present Eneash and ruining the day.
Well, if we get tuckered out on this or whatever, we're not committed to finishing all of them like on the air. I mean, but I'm not convinced that they have no value yet. So I think it's
Yeah.
worth pushing through. Yeah.
Yeah, agreed.
That brings us to next time we'll be talking about where philosophy meets science. And can you prove two particles are identical? I
Yeah.
believe the answer is spoiler alert, no. I think I might have had that backwards in my head. So this will be worth reading. All right, good times.
Yeah. The spoiler alert is there's only one particle, maybe.
Ooh, it's quite the spoiler.
um, Also, if somebody has a much solider grasp on quantum mechanics than the two of us and wants to drop like a 5 minute, 10 minute rebuttal explanation, nitpicking, going through what exactly we said was wrong in very simple terms, I'm sure we will be absolutely happy to post that as free extra content for the people who want it.
Yeah, 100%. And if it's fun, we can do a whole deep dive episode on it. I wouldn't mind learning this. It's just I don't know. I'm not convinced this is the way that is best for me to learn it. Let's put it that way.
Right.